Have you heard that NASA's James Webb Space Telescope was hit by an asteroid? Well, they got their revenge. Not exactly revenge, but they did make a spacecraft hit an asteroid on purpose. Yes, they did. So, why would they crash their multi-million-dollar spacecraft on an asteroid? Stay tuned! Welcome to another video of Theory of Science. If NASA can crash their spacecraft into an asteroid, what's stopping you from crashing the subscribe button? Go, and subscribe to our channel. Run! Came back? Okay, let's dive into our topic. I don't think we need an explanation about what NASA is, and we have all heard about NASA and its various space explorations. You all might be wondering why they crashed their spacecraft into an asteroid. Well, the purpose of it was to prevent asteroids from crashing into Earth in the future by literally crashing an aircraft into them. Crashing a spacecraft doesn't sound that bad if it's to protect Earth, right? Assume that a water balloon is targeted toward your friend who is sleeping. How would you save your friend from it? I guess you would rather wish your friend got hit by it. But what if you wanted to save them? You would most likely smash the water balloon before it reaches them, right? This works similarly, but in this case, it's not a water balloon, but an asteroid, and it's the Earth that needs to be saved. The spacecraft, almost the size of a vending machine, deliberately crashed into an asteroid. The $325 million mission was designed to identify whether crashing into an asteroid can alter its direction, providing scientists with a valuable real-world test of planetary defense technologies. The spacecraft self-destructed by ramming into a harmless asteroid. The moment of impact marked the first time in history humans have attempted to alter the direction of an asteroid. The test was called DART, or Double Asteroid Redirection Test. It was a test done for the Planetary Defense System. The Johns Hopkins Applied Physics Laboratory built the DART spacecraft at the direction of NASA's Planetary Defense Coordination Office. The spacecraft launched in November 2021 and spent 10 months journeying to its asteroid target. It then successfully crashed into the asteroid on September 27, 2022. Yes, you heard that right. It successfully crashed. The whole purpose of DART was to crash into the asteroid. Telescopes around the world captured the impact, and in space, they aimed at the same point in the sky. The objective was to test if they could crash into an asteroid to prevent future asteroid attacks on Earth. The spacecraft hit a little asteroid called Dimorphos, which was about 7 million miles from Earth. The small and harmless space rock Dimorphos measured 525 feet and orbits a much bigger, 2,500-foot asteroid called Didymos. Both Dimorphos nor Didymos doesn't possess any threat to Earth. NASA and its future is looking good, right? So, what are you looking at? Go subscribe! The scientists selected Dimorphos for the test because of its orbit around Didymos, which resembles how potentially threatening asteroids near Earth orbit around the Sun. Dimorphos' orbit wasn't locked to Earth or the Sun, but instead to Didymos. Another one of the reasons scientists chose to target Dimorphos was because of its relatively shorter orbit around Didymos. A deviation in this orbit was likely to be more noticeable and thus easier to measure if Didymos itself was targeted, and an attempt was made to measure the change in its orbit around the Sun. This makes it a perfect testing ground for NASA. DART deliberately hit Dimorphos at speeds of 4.1 miles per second, which is 14,760 miles per hour. The direct hit marked the successful completion of the first part of the planetary defense mission. An impact at this speed should cause the moonlet's orbital momentum to change by a fraction of a percent, and this shift should probably be enough to change its orbital period by a few minutes. According to NASA, the change in Dimorphos' orbit around Didymos will be analyzed and measured by telescopes on Earth to see if the mission has succeeded. The spacecraft's one-way trip verified that NASA could successfully navigate a spacecraft to intentionally crash into an asteroid for the purpose of diverting its direction. This technique is known as kinetic impact. Scientists insisted DART would not shatter Dimorphos. The spacecraft packed a scant 1,260 pounds compared to the asteroid's 11 billion pounds, but that should be plenty to shrink its 11-hour, 55-minute orbit around Didymos. NASA may take several weeks to validate any change in the space rock's trajectory, but if the DART team managed to nudge Dimorphos off course, we may have a practical strategy to avert off actually dangerous asteroids. The goal of the mission was to shorten the asteroid's nearly 12-hour orbit by a few minutes. Even a tiny change in an asteroid's trajectory could prevent a tragic impact. The mission can further be used to deflect hazardous asteroids that pose risk to the Earth. NASA predicted the crash would probably be strong enough to alter Dimorphos' orbital period by a few minutes. More specifically, the predicted calculations show the impact will bring Dimorphos closer to Didymos. The 11 million km is the closest the Dimorphos comes to Earth while moving around in its orbit. Dimorphos didn't pose any threat as there was no probability that the asteroid would have approached and collided with Earth. The collision was, therefore, just a technology demonstration and an experiment to assess the capabilities to face such challenges in the future. Don't worry, based on present knowledge, there is no real danger to Earth from asteroids for the coming 100 years at least, but asteroid collisions are actual and can happen. The problem is that these calculations are mostly based on asteroids that we know, but only about 26,000 are known. There are a lot of asteroids that we haven't discovered yet, and these could surprise us. The dinosaurs and most other life forms are known to have become extinct following an asteroid collision about millions of years ago. So this research might come in handy someday in the future. A camera placed on DART captured live views of Dimorphos getting more significant as it neared the asteroid. Finally, in the last minutes of DART, it was able to capture more details of the space rocks, which turned out to be rough and craggy. In the future, by using the knowledge gained from this mission, similar techniques and strategies can be used to divert an asteroid or comet away from our planet if it were deemed hazardous for the Earth. The 330 million carefully orchestrated collision was broadcasted live. With the camera placed on DART, the team of scientists and engineers, as well as the general public, could watch a 525-foot rock grow from a mere dot of light to a rocky boulder blocking the whole frame. The live feed almost unfolded in real time with nearly a 45-second delay, delivering an extreme close-up of an event that is happening 6.8 million miles from us. US Space Agency has labeled this the world's first planetary defense test. While the news of a spacecraft crashing used to be very devastating to the scientists, now they clapped and cheered as they watched DART crash into Dimorphos. DART is now completely destroyed. NASA successfully completed the 7-year program with the crashing of DART. Also, check out our other videos on our YouTube channel.